welcome to the talk on testing with Spring 4.3, JUnit 5, and beyond. First up, my name is Sam Brannen. I'm a Spring and Java consultant at a company called Swiftmind, and I've been a Java developer for over 17 years, so quite a while, and a core Spring committer since 2007 when I first rewrote Spring's integration testing support, so the Spring TestContext framework, all the annotation-driven stuff, and I've managed it since then. I'm also a lead for the Spring user group in Switzerland, in Zurich. I'm a trainer and a conference speaker, no surprise there. And last but not least, more recently, since last October, I've been a core committer for JUnit 5. So Swiftmind, just quickly about my company, experts in Spring Enterprise Java in general, focusing on Spring Portfolio, JUnit 5 now, as you might imagine, Java EE in general. We basically just do software architecture, code reviews, these kinds of things. And you can find us online in Zurich, Switzerland, but obviously we can travel as well. So the agenda today, start off, I'll just show you, give you a brief intro to an app that I use for some of the demos called Spring Events. And then we'll talk about the new features in Spring 4.3 that just came out recently. And then we'll talk about brand new JUnit 5, how far we've gotten, the features you can expect there, extensibility, and all these kinds of things. And then last but not least, we'll look at the support for JUnit 5 in testing coming with Spring 5.0. Then at the end, we'll have a Q&A session. If we have some time there, if you have a question during the middle, just feel free to raise your hand. So first up, show of hands, who writes tests? Everyone? Okay. Who doesn't write tests? Anyone brave enough to claim that? No? Okay. Who writes unit tests? Unit tests. And when I say unit tests, I mean not using Spring, not using embedded database, stuff like that, yeah? And who writes integration tests? And keep your hands up if you write those with Spring. Yeah? Okay, that's good. All right, who uses something like Spock? It's a testing framework, a few people. TestEngine? Okay, a few hands. And JUnit? Yeah, okay. Anyone write any tests with JUnit 3, just out of curiosity? Still nobody? All right, nobody on Android, stuff like that. JUnit 4, like up to 4.12, yeah? Most people? Okay, good. Good to know. So this Spring Events app, you can check it out. It's online. It's just an example I put together demonstrating a couple of different technologies with Spring and Spring Boot. It is a Spring Boot powered web app. Right now, I just recently upgraded it a few days ago to Spring Boot 1.4, the latest and greatest. Spring Framework 5, Milestone 1, which was just released, and JUnit 5, Milestone 2, which was also just released. So if you want to see kind of the latest technologies working together in terms of testing, I have to assume this is the most advanced app you'll find, at least this week on the internet. So basically, it has a simple POJO domain model with events, transactional service layer, using Spring Data JPA for the repository layer, Spring MVC time leaf, and a REST presentation layer, and all this stuff is tested. In addition, it also has Spring Security, and as I mentioned, the recent upgrade to JUnit 5. So if you're interested in checking that out, you can check out my GitHub account here, S. Brannen, Spring Events, if you want to download it and play with it later on. I actually just saw a tweet this morning. Somebody found it useful and upgraded their own app to Spring Boot 1.4 test and JUnit 5, and they said it was successful, so that's good news. So next up, first main category here, what's new in Spring Framework 4.3? Starting off, just some of the odds and the ends. As a base requirement now, you have to have at least JUnit 4.12, otherwise it won't work. But you'll get an exception telling you that otherwise. So that shouldn't be much of an issue, just a straightforward upgrade to JUnit 4.12. That's if you're using the Spring TestContext framework, right? So this integration testing support from Spring. The other stuff doesn't actually require an upgrade for JUnit. Another minor feature there is support for what we call primary transaction managers and data sources. So if you had annotated, for example, a bean with that primary and you had multiple transaction managers or multiple data sources, the Spring testing framework would now work the same as your production code and take the primary one if you didn't specify otherwise. Next up, who's ever heard of add-SQL for executing SQL scripts? A few people there. Okay, so you can basically have the Spring testing framework run some SQL scripts before your tests or after your tests for setting up the database or cleaning up. And these things can now be used as meta annotations. For example, if you want to create some custom composed annotations with attribute overrides, that's now supported. And the same is actually true for most @repeatable annotations. So if you're familiar with Java 8, you can have repeatable annotations, annotation declared multiple times on a method or a class or something like that. And basically this works for most repeatable annotations across core Spring now, so you can create custom composed annotations with those. Next up, reflection touch util. Some of you might have seen that for setting private fields and things like that in your POJOs and your controllers and stuff like that. And as of Spring 4.3, this will now automatically unwrap any proxies that were created for those things. So when you're setting and getting private field to unwrap the proxy, you might ask, how could that happen? Well, if you have a bean in the application context where you created a mock, like with Mockito or something like that, and you wanted to use reflection touch utils to set stuff in it, if it got wrapped in a proxy, this would then unwrap it. Or if you had a transactional bean there that got wrapped with AOP behind a proxy, this would unwrap it for you. Next up, a bit more low level in terms of extending the Spring TestContext framework. In 4.3, we have some new features. First up, the get TestContext method in the TestContext manager is now public. If you don't know what the TestContext manager is, you probably don't care. But if you're integrating with Spring, this makes it more reusable and was a necessary change in order to support JUnit 5. Next up, we have a new ContextCustomizer API, and those things can be configured or created via ContextCustomizer Factory. Basically, this can replace potentially the need for creating your own custom context loader. So if you have some integration code where you're creating the application context on your own with Spring, this might be a better alternative for you. And what it does is basically allows you to customize the application context after the bean definitions have been loaded, so after Spring knows about all the beans it's supposed to create, but before the context is actually refreshed, so before it started, so you can add other beans. For example, if you saw the @mockbean support from Spring Boot, that's actually how that works. And these things are registered globally using the Spring Factories mechanism, so kind of like the service loader mechanism. Yes, and exactly, so this is what enables a lot of the new Spring Boot test magic in Spring Boot 1.4. So there's stuff like @mockbean, it actually uses this feature. And if you wanted to do something similar, you could, of course, do that on your own. Some new features we saw in the keynote yesterday. If you're tired of typing Spring JUnit 4 class runner, can't remember the name of it, there's now an alias called SpringRunner. So you can just very easily type in @run with SpringRunner.class, and we'll see later on that that aligns with the JUnit 5 support, which is called the Spring extension. Another feature that was kind of driven by Boot here is the ability to omit the @context configuration annotation completely if Spring can detect default XML files or Groovy scripts or @configuration classes. And in the case of Spring Boot Test 1.4, that does some other magic there. So Spring Boot will actually use class path scanning to find your configuration class that's annotated with that Spring Boot application. So basically just less to type in as a feature here. Another important feature, a lot of people who have very large test suites might have several different sets of configuration for that application contexts, and those all get loaded and cached in memory, so you might run into memory problems. So what we added in 4.3 is support for a bounded cache. So the application context, those that are loaded for your tests, they're now in a cache with a maximum size of 32 as the default number, and that basically uses an LRU, least recently used eviction policy. So the last, or the application context that was least recently used will get evicted if another one is loaded in. And that should work fine in most cases. But if you don't like that, if you want to make it smaller, or if you want to make it bigger, hopefully you don't want to make it bigger because that's usually a bad code smell that you have too many different configuration sets. But if you wanted to change that, you can set that via the Spring Test Context Cache Max Size JVM or System property. So let's take a look at that in action. Where are we? Let's see. So I have an example here with JUnit 4. Can people see that? Yep. Because this is the run with Spring JUnit 4 class runner, we could run this class and see how long it takes. So it took about 3 seconds there. And the first thing I was saying is you could drop this Spring J4 class runner and just switch to the SpringRunner, and that should still continue to work. The other thing we said is that at context configuration, right here it's empty. You might want to configure it with some other classes, configuration classes or something like that, but by default it's going to look for a configuration class in the same test class, so a static nested configuration class, which we have here. So we can see that now in Spring 4 we can just delete that declaration, and it's hopefully going to work just the same, right? So just a bit less typing, and that works just fine. Now in terms of this context caching, I have a test suite. This is using JUnit 5, we'll get to that later, but let's just run it and kind of see what happens here in the console in terms of logging. So it's going to take a little while. It has several different application contexts. It might take about 20 seconds, potentially. And after this runs, we should see lots of context cache statistics. So we see stuff like this, that the context cache, the size is 3, the max size is 32, right? That was the default. And we had a hit count of 91 and a miss count of 3. So that's good. There's not much churning going on there with the defaults. And I think if we looked to the very bottom, we'd see, okay, the size is still 3. And if we wanted to switch that up, to change it, just to show you that that actually works. Hopefully I can do that easily by changing the run configuration and specifying this. Okay, so I don't have that. Let me grab this property here, property name, and I should be able to set in something like a -d, and then set that equal to 2, and then we should see that it wouldn't be bounded by 2 with a max size. So if you had taken up a lot of memory and you wanted to reduce that, you should be able to configure that pretty easily. So we see already the max size is 2 for all of these, and at the end, obviously, we should have slight changes there at the bottom. So the miss count was still 3, hit count 93, but now the size is 2 at the end, the max size is 2. So if you have any issues with caching, you can configure that now. Okay, now in terms of preparing for the future, just kind of changing some things in the core testing framework to support things like what we call testing traits. Basically, Spring test annotations can now be declared on interfaces, right? And this combines nicely with Java 8 default methods. So if you're not on, actually, who is on Java 8, out of curiosity? Okay, about half of you, right? So maybe you've heard with Java 8, you can have default methods and interfaces, and that means you can have implementation, right? You can have behavior with your interfaces. And this allows you to do things like traits that come from other programming languages. So you can have some basic testing functionality in an interface and implement that in different test classes. So this combines nicely with JUnit 5 as well. Another thing in this direction, transactional test methods no longer have to be public. You might not care at the moment, but as you move to JUnit 5, you don't have to have public classes or public methods, so you'll probably just get used to not typing public anymore. So it's best if Spring also kind of works in the same way there. And that also holds for TestEngine. The same is also true for at before transaction and at after transaction methods supported by Spring's transactional testing support. Those no longer need to be public. And in addition, those can also be declared on default methods and interfaces. So you could have like a transactional test trait that does some stuff before your transactional tests and after them, and you could basically implement that testing trait in several test classes. Another option would, of course, be to have an abstract base class, but you might find that these kind of testing traits suit your needs better. Now we'll switch to some improvements in the web testing scenarios. So for Spring MVC Test, we have the MockMvc that we can use there. If we have response headers that have multiple values, we can now set expectations on those. That wasn't possible previously, and that's via a new string values method, plural there with an S, and the result matchers, so you might find that useful. Another feature now is the form data request content. For example, if you have a post, Spring MVC Test will now parse that from the post and use it to populate request parameters in case your controller is actually using those as request parameters. Another feature that was requested is support for custom HTTP verbs. So Spring MVC Test naturally supports things like get, post, delete, these kinds of things, but maybe use some kind of custom verbs like WebDAV, and that's also now supported with a new request method on the builder that takes a string for the method name, the HTTP method name. And if you're using the HTML unit integration support with Spring MVC Test, if you ran into any issues with cookies, there have been a couple of improvements there, so hopefully we resolve those. If not, then just raise an issue and we will look into it. Another cool feature with Spring MVC Test now, you can now assert which handler method was invoked with a Bach-like feature. You could have done it in the past just based on the name, but now there's a new method call assertion in handler result matchers. And you can assert, so the controller method that was actually invoked to serve the response. Under the hood, this uses MVC URI components builder, which is part of Spring MVC, not part of the test. And I'll point that out in the example here. So let's assume we have a home page and we have a home controller that populates some data to be displayed in the generated HTML. So let's say we have, for example, a home controller class, and it has a show homepage method that has an @request mapping for get to /. So if we're using Spring MVC Test, we can now say perform the get request, and now we're going to expect that the handler method call was on this home controller and this method. So this on thing here, this is a static method that's imported from this MVC URI components builder. So you can now be very explicit and type safe in terms of how you're verifying these things, right? So even if you refactor, the test would refactor along with it. Next up, JSON prefixes. Who's ever heard of a JSON prefix? Anyone? No one? Okay. So, well, we have support for it. Now we can strip it off in Spring MVC Test. Basically, you would want to use a prefix to prohibit what's called JSON hijacking. So if someone, some malicious hacker tried to have a script tag that loaded your JSON content with a GET request and then view the contents of some sensitive data, that would be JSON hijacking. And to avoid that, several companies, for example, like Google, they prefix their JSON content return from their REST web services with just something that doesn't compile with JSON, right? So here it might be prefixed with something like and, enigma, and. If that's the case, then you can tell Spring MVC to strip that off. So this is just standard Spring MVC to a JSON REST service here, and we're saying we want to get the PIN number out and verify that it's 1234, but please strip off the enigma prefix there. So that's supported in Spring Framework 4.3. So that was server side, right, when you're testing your own controllers you write or your own REST endpoints. And now we'll talk a bit about some new features for client side, right, when you're using the REST template to talk to a remote web service and you want to mock that out. So for that, there's the MockRestService server. And you can now set expectations for the form data in the request that you're sending via the REST template. And that's in this new form data method we see here on the request matchers. You can also specify expectation counts. So I think this is pretty cool, pretty useful feature here, and also a nice API for this. Basically what you do is you pass in an expected count to the expect method on the mock. And those are static methods. We see several of them here. Things like once, right? So this is similar to what you would see in Mockito or some other framework like that, right? I expect this thing to be called once or many times or just twice or maybe somewhere between 2 and 5 times, right? Things like that. And you can then at the end verify, reset if you want to, right? And so then the verify is going to obviously throw an exception if your expected count expectation is not met. Another feature here, you can specify whether ordering should be ignored. So you specify multiple things that should be invoked with this REST template or multiple requests, and you can set, for example, the ignore expect order to true if you want that to be ignored. On the builder, you just invoke another method in between. So normally with the builder, you would say something like MockRestService server bind to your REST template there, and then build. And then the new feature here is just say ignore expected order. So it doesn't matter the order in which those things occur. So that's it for Spring 4.3. Now we're going to dive into JUnit 5. So who had heard of JUnit 5 before this conference? 6 people? 7 people? Not too many? Okay. Who has actually tried it out? Anyone? Few people? Okay. All right, so hopefully this will give you an idea of what to expect in the upcoming JUnit 5 and where hopefully the world is going in terms of testing on the JVM. So the impetus for change, let's start there. JUnit 4 was released a decade ago, so quite a long time ago. A lot has changed since then. Particularly testing needs have matured. People don't write just unit tests. People write integration tests, system tests, end-to-end tests, and they do that all with JUnit. So one thing I tell a lot of people, it's unfortunate that JUnit is called JUnit because half the time now we're not writing unit tests, but the word unit is in there. So don't get confused, right? You can use JUnit to write any kinds of tests, basically. But in addition, expectations have grown. So people expect more features that make integration testing easier in their testing framework that was originally written for unit testing, right? So we need some new extension models for third parties to come in and provide additional support. In terms of modularity, with JUnit 4, I say kind of jokingly, big ball of mud. Not in terms of the internals, but basically there's just the one big monolithic JUnit jar. And that means use it as a developer, use that as an extension writer, use that as the IDE or the build tool. Everybody uses the same jar, and that kind of makes it difficult for JUnit itself as a framework to evolve. Another thing, test discovery and execution. Those are tightly coupled. So again, this is all coming back to kind of the idea that there's only the one JUnit jar, and it's not really that easy to extend or for IDEs to integrate that well with it. And extensibility, so something like a framework like Mockito or Spring wanting to integrate with JUnit, there's a lot of room for improvement there in terms of JUnit 4. And let's not forget, right, so what's happened more recently, Java 8, things like Lambda expressions, method references, streams, and these kind of things. These are things that JUnit 4 can't support because JUnit 4 is based on, believe it or not, Java 5, which is quite old these days. The runner, so if you used Spring, right, you've seen the Spring JUnit 4 class runner, or maybe you've seen the Mockito runner, stuff like that. That's the basic extension model in JUnit 4 from the start since JUnit 4.0. It's very powerful. In fact, it can do anything, but you have to do everything if you're the one writing this. And another big downside, it's physically impossible to combine runners. You can say run with this runner, and that's it. So case in point, parameterized, very popular from JUnit itself. The SpringRunner, also very popular. Over the years, people said, I want to have parameterized Spring tests, and that was just physically impossible, so room for improvement there. Next up, to address some of these issues, the JUnit team introduced rules, and if you read this, I would say rules are meant to be broken, we know that, and JUnit rules are also meant to be broken, and actually were, in fact, kind of broken all along the way. So in JUnit 4.7, there's support for method-level rules. In JUnit 4.9, support for class-level rules. The downside is you have to implement them separately. They're great for simple use cases. They can even be combined, so it's a big step up from the runners. But you can't use a single rule for method-level and class-level callbacks, which might not mean so much to you, but it means a lot more to an integrator like Spring trying to provide additional support to you as a tester. Plus, there's zero support for what I call instance-level callbacks, which something like Mockito or Spring needs in order to inject dependencies into your test. Case in point here, I'm not sure if you're familiar with it. About a year ago, we released support for rules in Spring's testing support, but to get that to work, I had to write 2 rules. I had to write a Spring class rule and a Spring method rule, and then kind of write some hacks to get them to work together. And that's obviously not the nicest for Spring as an integrator, but also not the nicest for you because you have to define 2 things and copy and paste this code everywhere. So, in order to address these issues, we started the JUnit Lambda crowdfunding campaign, Lambda because of Lambda expressions and new things coming in Java 8. And it was initiated by a guy named Johannes Link and Mark Philipp in Germany, and then later joined by 2 other Germans, Matthias Mertes and Stefan Bechtold, and I joined later on as well. That ran from last July through last October. If you hear last year, you heard some of the announcements about joining in and contributing for this. In the end, we ended up raising almost 54,000 euros from 474 individuals and companies. And 4 companies donated 6 weeks of developer time, including Pivotal, who's the organizer of this conference. So thank you if you donated. I know there's some people here who did, and some companies. And again, we see Pivotal listed up here twice, once as a cash donation and once as a donation for supporting a developer. So we got pretty far with that. We started off with a kickoff meeting last October, and we see the team here. We had some big names in the industry coming in and helping us decide on the direction we needed to go. So obviously we had our own ideas as developers, but we figured it's probably a good idea to ask some IDE developers and some build tools. So we had some people there from a developer from Eclipse, a developer from IntelliJ, a developer from Gradle, people from a guy from Pivotal, Oliver Gierke, some of you might recognize him there. I'm also on the picture as well. So had a good time, lots of good discussions, a lot of prototyping in that first initial week, and then we began real work with just a core 5 developers. So we actually delivered a prototype tagged in the repository last December. We released an alpha back in February, and then we worked long and hard between February and July, and we released the first milestone early last month. Then, as it often goes with projects like that, right after that milestone release, we discovered some bugs, so we released a milestone 2, just went out a few weeks ago, and that's what Spring 5 now builds on. So that's pretty stable, has all the core features you need, and we'll dive into that in a minute. In terms of where we're going from here, we hope to get some additional milestones out this year, and hopefully a release candidate in the fall, and then maybe, potentially, a 5.0 GA release by the end of this year. I mentioned we had the crowdfunding campaign. Unfortunately, all that money is gone now. Lots of hard work put in, so now the team is also down to 3 individuals working only in their free time, so can't really promise we'll make it by the end of the year, but we will do our best to achieve that. So what is JUnit 5? We've already kind of mentioned why we want to have it, why we want a new JUnit. First up, in contrast to JUnit 4, JUnit 5 is modular. It's also very extensible. In fact, the Spring integration, I wrote Spring integration with JUnit 3, JUnit 4, JUnit 5, and TestEngine, and the easiest integration so far was the integration with JUnit 5. So it's much easier for anyone to integrate into JUnit now. We like to think it's modern. You can be the judge of that yourselves. But one very important feature is it's both forward and backward compatible at the same time, which might sound a bit tricky. We have actually achieved that. So basically, we have this idea of the JUnit platform. And the JUnit platform supports JUnit 3.8, JUnit 4, and JUnit 5 all at the same time. It also can support any other kind of frameworks now, so that's a very big plus. So new testing frameworks can be run in addition with the existing JUnit 4 infrastructure with JUnit 5, so you have lots of opportunities there to combine things. To get the platform running, the easiest way right now is to actually use JUnit 4, the JUnit 4 running infrastructure there at run with, and then JUnit platform as a class. And then you can basically set up a testing suite that you can launch JUnit 4 tests with, JUnit 5 tests, maybe something like Kotlin or Spexy or some other test engines, and we'll get to that more in a minute. So another big thing about JUnit 5 is that it's not just JUnit, kind of the programming model, the way you kind of think about JUnit 4. So JUnit 5 is actually a combination of 3 things. It's a combination of what we call the platform itself, Jupyter, and Vintage. So the platform, we've assigned that a 1.0 version, and that's the foundation for launching testing frameworks on the JVM. And that's not limited to JUnit, right? That's anything on the JVM, any programming language runs the JVM, it should work with the JUnit platform. For that, there are launcher and TestEngine APIs, and we'll talk about that in a second. There's also a console launcher for running from the command line. We have written our own plugin for Gradle and our own plugin for Maven, so you can actually have stuff running in the build, even though Gradle and Maven don't support that officially yet on their own. We hope to hand that off, and IDE support, that's also in the works. JUnit Jupyter. So JUnit Jupyter 5.0 is actually the new programming model for JUnit 5. But it's also the new extension model for JUnit 5, so that's what you're going to be using the most as a developer. And then JUnit Vintage, We had some different ideas about what to call it. Basically, it's all the old stuff, the legacy, or what will eventually be legacy. So everything that runs now with JUnit 4, we call that JUnit Vintage, and we have a test engine that integrates all of your existing code, existing tests into the JUnit platform. So this launcher API, if you're interested in writing some kind of build support or ID support or maybe some kind of your own standalone application to run your tests, you can use that, but primarily it's going to be used by the IDEs and build tools to actually launch the platform or the entire framework. And it's a central API for discovering and executing tests via one or more engines. So in JUnit 4 we had runners, and in JUnit 5 we have engines, if you want to think about them kind of as an analogy. To tell the JUnit launcher what to run, there's a launcher discovery request, and that supports things like selectors and filters. Selectors would be things like select this class, select this package, select this method by its unique ID or something like that. These are the things I want to run, and I want to filter stuff out. Don't want to run things that aren't tagged with this, things like that. And those engines can provide feedback via the Test Execution Listener API. So if you're familiar with Spring, with the TestContext framework, don't get confused. Spring also has a Test Execution Listener interface called the same thing, but they're not the same. So this test engine, again, this is kind of like what a runner is in JUnit 4, except that we don't expect that many people to write their own engines. Since JUnit 5 is much more extensible, we assume most people will just use the Jupyter engine, so the JUnit 5 programming extension model, and provide extensions. But you can write a test engine, so if you want to support something completely different, maybe something like based on XML files, maybe something like Cucumber, maybe something different like Scala or Groovy or something like that, you could write your own engine. And in fact, people have already begun doing that. One guy's already started support for his own framework called Spexy that runs Java, Groovy, and Scala. And from IntelliJ, one of the developers there is developing a spec for Kotlin testing framework. So these test engines, they're responsible for discovering and executing tests, but limited to a particular programming model. And that's key, and that's actually the way the JUnit 5 or the platform can support JUnit 5, JUnit 4, and JUnit 3 at the same time in the same test run. That's because we have different annotations, so the classes look different. So the engines know, okay, this is a JUnit 4 test annotation, so I can run it if it's JUnit 4, and the JUnit 5 side says, this is the annotations for JUnit 5 Jupyter, so I know how to run that one, and then there are no collisions in terms of what's in your class path and everything. The way these things are registered, that happens automatically with the standard Java service loader mechanism. So if you have the jar in the class path, if you have the Jupyter one or the Vintage one, then the platform will just automatically find those, and you'll have support for that test engine automatically. So for JUnit 5, there's the Jupyter test engine. For JUnit 4 and JUnit 3, there's the Vintage test engine. And that would also count for stuff like Spock or anything like that, right, that's based on JUnit 4. And you can, of course, implement your own. Now, picture is worth 1,000 words, right? So here we have the platform big in red here at the bottom, and the IDEs and build tools are going to see that side of it, right? So they're not going to focus on the programming models. They don't care. They just want to be able to, say, launch tests based on these classes, based on these paths, these XML files, these patterns, stuff like that. And at the top, you see you can have different frameworks that are tied in to the platform. Here we have Jupyter. Again, this is the JUnit 5 programming model, Vintage supporting JUnit 4 and 3.8. And here, as an example, any third-party test engine, as I mentioned, this Spexy framework already has its own support for JUnit 5. So in terms of the internals, what that looks like inside, if you're writing a test against JUnit 5, the only thing you actually care about is the API, like the annotations and the assertions and stuff like that. You don't care about the internals or about this launcher or these test engines or any of these other things. So your code just depends on that. And then this JUnit Jupyter engine in the middle, it supports the programming model there and then communicates with the launcher. So this all hooks in together. And then the same is true for any of these engines. We see inside, talking about integration with build tools. So we have the Maven Surefire provider here, the Gradle plugin down here. This one's using the console launcher. And here we have this JUnit platform SpringRunner, which is that what I showed you earlier with at run with JUnit platform. So in terms of the extension model, we start with the extension model instead of the programming model, just because it kind of helps to have a good idea of what kind of extensions there are, and then you can kind of understand how the features work with the extensions. So to start with, there is an extension API, is an interface, but it's just a marker interface, and that makes it easier for us to have them all registered via annotations. This is located in the org JUnit Jupyter API extension package. So one thing we've done to make sure there are no issues with the class path, right? Instead of just doing everything in org JUnit like was done in JUnit 4, everything in Jupyter has this Jupyter name there in the middle. So that alleviates some of the problems one might run into with the class path in different versions. So this package contains all of the extension APIs. They're all interfaces. You can implement one, or you can implement all of them. I think there's something like 13 right now, and the Spring extension implements something like 8 of them. So you implement as many as you need, tying into the functionality that JUnit supports. Another thing is you can register multiple at the same time, and we talked about this before. At extend with, so again, JUnit has the runner, and JUnit 4 has the runner, JUnit 5 has extensions. JUnit 4 you would have said at run with something, JUnit 5 you say at extend with. And you can register one thing like the Spring extension, or you could register something like a Spring extension, some kind of parameterized extension, Mockito extension, all those things at the same time, and there's no problems there, right? So that's a big improvement over JUnit 4. And where you can declare this at extend with annotation on an interface. So for example, if you have like a testing trait you're developing on your test class itself, or on a test method. Those are the ways you can declare extensions. And another feature, you can also declare it as a meta annotation. I'll show an example of that later. Third-party extensions would often want to do that or need to do that, but you can also do it for yourself to reduce the amount of configuration in your testing suite. So in terms of these APIs, we have test lifecycle callbacks, as we can see here. At the top, we have before all, and these things wrap, right? So we have before all at the end and after all. This is analogous to before class and after class, if you're familiar with that from JUnit 4. Then inside, we have a before each and an after each. They wrap around. This is like the at before and the at after kind of in JUnit 4. But these are the extension points for that. And then we have a lower level that we don't have with JUnit 4. So extensions can actually do something immediately before the test method is executed or immediately afterwards. So again, for example, the Spring extension implements all 6 of these. Another feature we have is what's known as conditional test execution. That can be applied at the container layer level or the test execution level. One thing about JUnit 5 is we try not to focus too much just on Java classes and methods. So when you see container, in the general case, it means a class. And when you see test execution, in the general case, that means an at test method. Next up, test instance post processor. Has anyone ever heard of a bean post processor in Spring? A few people. So this is inspired by that. Actually, a lot of the features in JUnit 4 are actually, JUnit 5 are inspired by frameworks like Spring. So this is kind of like a bean post processor, but it's the test instance post processor. So an extension can do things like read fields or inject fields. Something like Mockito might do that, and Spring, for example, uses this. Next up, parameter resolver. Anybody ever used Spring MVC? Yeah? At request mapping methods, yeah. And you can add all sorts of parameters like the request, the response, your domain model, this kind of stuff. So that also heavily inspired JUnit 5. We have a parameter resolver, which is similar to the support there in Spring MVC, and that allows for things like dependency injection for constructors and methods. Last but not least, we have a test execution exception handler. That's if you wanted to write your own kind of extension for logging exceptions that were thrown, or maybe your own expected exception extension, you could do that. So that would be invoked right after the test method is executed, and you'd have access to the exception that was thrown, if any. So now that we have an idea kind of about the extensibility, let's dive into the programming model in a whirlwind tour. Okay. So everything you need as a developer is in the org JUnit Jupyter API package. Basically all you need. We have support annotations in there, also support for meta annotations. We have assertions and assumptions, custom display names, and I'll be showing some examples of these things. Visibility, I mentioned that before. JUnit 5 is no longer stubborn, or as stubborn as JUnit 4 was in some ways. You don't have to make your classes public. You don't have to make your test methods public. As long as they're not private, JUnit will find them and execute them. After all, JUnit uses reflection anyway, so it's no big deal there. Tagging. Who has ever used something like test groups in TestEngine? A few people? Who's ever used something like the category support in JUnit 4? A few people heard of that? So one idea is you have groups of tests. You have some things that are long running, right? You know, a slow test or some fast tests. Maybe you want to say these are my unit tests, these are my integration tests, these are my CI, my continuous integration server tests, and you want to just tag them, right? So that's supported in JUnit 5. And basically, in the future, all IDEs and all build tools will allow you to configure which tags you want to run. So you could have multiple different configurations on your build server, like running the slow ones, the fast ones, etc. Conditional test execution, talked briefly about that before. Dependency injection as well for constructors and methods. Also support for Lambda expressions and method references in things like assertions and timeouts, and also dynamic tests, we'll get to in a second. Support for interface default methods. Nested test classes, that's definitely a new kind of way of writing tests, and we'll talk about that in a minute as well. And last but not least, these dynamic tests, which will help more with an example. So that's just kind of an overview of what there is. In terms of the annotations, surprise, we have an @test annotation. We couldn't come up with anything better than that, so it's called the same as in JUnit 4 and pretty much anywhere else. One difference here is this does not have any attributes or parameters that it accepts. It doesn't accept a timeout or an expected exception, because we expect you to do that in a different way with lambdas and stuff on Java 8. Also, @test factory is for dynamic tests. @before all and @after all, again, these are like @before class and @after class in JUnit 4. @before each and @after each, you can put these on methods that you want to execute before your test method or after, analogous to an @before method or an @after method in JUnit 4. Next up, we have this @displayName. That's for providing a custom display name. @tag, mentioned that before, that's how you declare it. And @disabled is like @ignore from JUnit 4, also accepting some information there for why it's disabled. And @nested if you want to have these nested classes. In terms of assertions, we have the JUnit Jupyter API assertions class, somewhat analogous to the Assert class from JUnit 4. We provide there a limited set of core assertions, basically mapping onto what you're already familiar with from JUnit 4. Things like assert equals, assert not null, assert same, these kind of things, assert array equals. We have support for all of those common cases. But we have some new things, more powerful. So we have stuff like assert throws and expect throws, so that you can assert that an exception is thrown by a given block of code that you provide via a Lambda expression. So this is what you do instead of having the expected exception rule or the expected exception at the test level, stuff like that. Also, recently, just added this in a week ago, support for asserting timeouts on blocks of code, also provided via a Lambda expression. So this is kind of where this builds upon and goes a step further than what you had in JUnit 4. Another cool feature, has anyone ever been annoyed if you write multiple assertions in a method and you change some code and you run the test and the first one fails and then you go fix some stuff and you run the test again and then the second assert fails and then you fix some stuff and you go back and the third is, anyone have been annoyed by that? Yeah? Has anyone ever heard of soft assertions from AssertJ? Maybe? Okay, so that's something AssertJ does, different way to do it. What we have is assert all, and then we allow you to provide all of the things you want to assert as Lambda expressions, and JUnit will invoke all of those, catch all the exceptions, and then collect all the exceptions. So it's really nice if you're checking something, maybe like you have your equals method maybe only depends on the ID of something, but you have like a person as a first name, last name, street address, all these kind of things, and you want to assert all those and see all the failures together. You can do that nicely with assert all. Next up, the one thing you'll notice if you're trying to migrate from JUnit 4 to JUnit 5, all of the messages, the error message you can provide to an assertion, they all now come at the end as the last parameter. So you have like assert expected, expected actual, and then the message. And another thing that's cool with Lambdas, you see this in logging frameworks as well, lots of places these days. If you're familiar with suppliers, so this is a functional interface. Supplier string is just some little thing that provides a string, so your error message, and you can use that for lazy failure message evaluation. So that means if you have a toString method or some kind of error message you're building up that takes a long time, there's no reason to execute that if there's no failure. So this allows the testing framework to evaluate that lazily, basically speeding up your tests or your test suite, which is always a good thing. And if you don't like all this stuff, or if you don't need this, or you prefer something like AssertJ or Hamcrest, then that's totally supported. Those things throw assertion errors and other exceptions, so there's absolutely no problem using those instead of the assertions from JUnit. Next up, assumptions. Basically building on the concepts from JUnit 4 there. This is in the assumptions class. A limited set of core assumptions. Again, this is for aborting tests mid-flight. So a test condition would have a test skipped before the test is executed, and an assumption that fails is going to abort a test mid-flight. So the test has already started, and then for some reason you decide you don't want to continue because this file's not there, or this isn't available on this server, or something like that. So there's the standard support for things like assume true and assume false, and also supporting Lambda expressions here with a Boolean supplier. Instead of just a Boolean, you might have something that generates a Boolean. And again, for the messages, you can use a supplier string just like with the assertions. Another feature is that we have this assuming that. So you're assuming that some assumption is true, then execute this block of code, which is a Lambda expression. So you might say, assuming that I'm on the CI server, then additionally run these assertions, but otherwise continue. So don't stop the test, but just only run this conditionally is kind of what it is. You might think of that as a glorified if statement, and if you prefer an if block, then you could do that in addition. So now I'll try to do some live coding here. And what's my claim? Tests and assertions, right? So let's go for it. So for starters, as I mentioned, things don't have to be public, right? So you can have a test class, and then you have a test method. Don't pick the org JUnit one, because that's going to make it JUnit 4, right? Pick the org JUnit Jupyter API one. And again, this doesn't have to be public, so, oops. That should be a perfectly legitimate test. Now, in terms of IDE support, Eclipse doesn't have any support built in yet for detecting and running the JUnit 5 tests. The latest version of IntelliJ does, the latest beta version, 2016.2. So one thing you can do in the interim is a temporary workaround. Might sound strange, we're going to use JUnit 4 to run JUnit 5. Okay? So run with, and we have a JUnit platform runner, and I'm going to add the public on. Why does the public has to be there? Because JUnit won't run the class if it's not public. So just ignore these two lines, okay? They're not there. In the future, you won't ever need to type them, but for right now in Eclipse, that's the one way to do it. So now I should be able to run this, and not too exciting, didn't assert anything, but it's there. So there's our first test. One thing you can see at the bottom that's slightly different, we have this. So this is basically a test suite. And then what happens is the platform finds all of the engines, the test engines, and it runs all the tests for those. So the test engine we're using, the JUnit 5 programming model, is JUnit Jupyter. So that's why we see that. And then we see our test class, and then we see the test method. And of course, we should be able to fail something. Shouldn't be too exciting, but that should work as well. So there we have the failure, right? And double clicking should jump right to it. That's good. So no problems there. Let's try an assertion. How about assert true? And let's say false. So we would want that to fail, but now this exception can come the message can come at the end, right? So the string message comes at the end. That works, and we see down here, failure, false. Now what if this were some kind of complex string we were generating? Then what we could do is we could create a Lambda expression here on the fly and say complex, if I can type, sorry. complex message, something like that. So this is our Lambda expression we're providing here, right in here, and if we run this, then that gets evaluated lazily. But again, if this were true, the benefit of that is this does not get evaluated unless the assertion fails, right? So that's how you can potentially speed up your test. If you have, I've seen tests where people actually end up checking stuff in the database to try to give more context, and that's obviously going to take more time, and you don't want to contact the database every time you run an assertion, right? Stuff like that. Some of those other things, we're talking about assertions for exceptions. So what if I want to assert that something throws an exception? I can use this assert throws, and I could say I expect maybe a runtime exception. So I can't type, sorry about that. And then this would need to be a Lambda expression. So we have some potentially a block of code, maybe like this, that does some stuff. Let's assume we're calling something in our service layer that throws. I'm having a hard time typing while standing. New runtime exception. Okay, now if we run this, that should pass. If we change this to just exception, that should fail, we would hope, right? So here we have this error down here that says expected type thrown to be runtime exception, but was Java Lang exception. And you could, of course, provide some kind of error message here as well. Oops, did I get that wrong? Or this one, sorry. We have not added that support yet. Ignore that. Okay, in terms of timeouts, is that not working? So let's ignore that for a second. I don't have that. That's in the M3 upcoming milestone, so it's in a snapshot. But I can show you an example of that in a demo that we have. If I can find that, maybe, or I can just add one. So add timeout, and then the way this works is with durations. So you can say like duration of amount, which would be something like maybe 100, and the timeout should be temporal unit. Is that not working? Right? Yes. Sorry, why is this not working? The demo gods are not with me today. Well, you don't want to waste our time. I'll just show you in the user guide. That's there for sure. So we have this support for stuff like this. You can say assert timeout of milliseconds, so 10 milliseconds, and then something that may take longer or less. And this one takes 100 milliseconds instead of 10, then that would throw an exception. And you could have things that pass right if they don't take much time. The one side we have what's called a lazy assertion in the timeout, so it's just going to let the code run. And then at the end, if it took too long, it's going to throw the exception, but that runs it in the same thread, which you might want if you have some kind of framework using like thread locals. For example, something like Spring for transaction management uses thread locals. Whereas on the flip side, if you wanted to use a preemptive timeout and have this code executed in a separate thread, we have assert timeout preemptively. They would launch that in a separate thread using an executor service and then end that task if it doesn't end on time. So we have all that support. Okay. Test names. Names by default, like you're familiar with Java, JUnit for example, right? They default to the test class or the test method names, and the characters are going to, of course, be limited based on the Java syntax. So one feature from other things like Spock or other testing frameworks is you can have names with spaces and special characters and stuff like that. So if you want to use that, you can use the @displayName annotation. can contain special characters, even emoji, which is something most people find quite amusing. Dependency injection. So this is where the extension model meets the program model, because someone has to perform the dependency injection, but you can make use of the feature. Again, there's this parameter resolver extension for that, for constructors and methods. And test info, if you knew about like test name and stuff like that from JUnit 4, with JUnit 5 there's a test info. You can have that injected into your constructors, your @test methods, your @before each, etc. And you can get access to things like the custom display name, the tags associated with that, the class, the method, etc. And in the background, if you want to see how it's implemented, there's a test info parameter resolver extension that does that for you. You can also see the test reporter, which is a way to add additional information to your test report for a particular test. The Mockito extension is an example we've written, and we're in communication with the Mockito team that will eventually take that over. And of course, the Spring extension performs dependency injection. So for the display names, should be able to show that pretty quickly. Getting rid of this one. The name there before was just first test, right? So if I wanted to say display a name, my first test, something like that, and then run that, we'll see down here, right, my first test shows up. The downside is, since the IDE doesn't know how to handle display names, if you double click on that, it's going to complain saying something like method my not found. But in time, that will be resolved, of course. And the other thing I wanted to show is if I can, I have an emoji here that I can just copy and add that in. If I wanted to throw in the emoji and run the test, then, wow. See, you can even have emoji in it. Yes. Surprisingly, that's the only thing everybody claps for when I talk. I don't know what that says about our community, but emojis are cool. Yeah, the current support in IntelliJ for some reason does not display the emoji, so I don't know. But in Eclipse, if you run it like this, it will display the emoji. And also from the command line in your build reports, you can see emoji on your CI server and stuff like that. The test info, I'm not going to show, well, I can show that really quickly. So in terms of this dependency injection, you can have the test info injected, and for the sake of time, I'm just going to print that out. Rerun the test, and we should be able to see in the console, hopefully. No, what did I do? Does it not compile? Because of this one, yes. It's no longer throwing a runtime exception, we'll just ignore that. So now we see in the console, right? So this is the information, right? If you need that, test info has the emoji as well. No tags were declared, we could have done that. And then you can access the test class, the test method, and other stuff like that. So for reporting, or if you need to do something conditionally based on that, you can. So tagging, you just declare @tag on a test interface class or method. For example, we see like this, @tag fast and @test. So this is a fast test. By default, all tags are basically ignored, but if you say only run with these particularly included tags, then fast would have to be declared as one of the tags for this run. Another option is to use meta annotations, coming up with custom compose annotations. So you can declare @tag as a meta annotation on your own annotation. Maybe we have something like this fast test that we want to reuse across our code base. Again, this would not have been possible with JUnit 4 because JUnit 4 didn't allow things like @test to be declared on annotations. But like Spring, JUnit 5 now allows this. So here we're saying @tag fast and @test, right? That's like we had on the previous slide. These two things here, we've moved them to our own custom annotation. And then we can just say @fast_test on our methods, right? And you could also have other stuff. You could even configure stuff like, imagine Spring's @SQL to run some scripts, or @transactional, all that kind of stuff. So you could have like fast transactional tests. Pretty cool options here. Conditional test execution. Again, this is where the programming model meets the extension model. These two types, the container level and the test level. @disabled itself is an implementation of one of these, or actually both of these combined. And there's a disabled condition. You can look up the source code for that if you want to kind of see how to write your own. One of the really cool things, and the reason, the next statement, eating our own dog food, we didn't want to make @ignore like in JUnit 4 where it's just hard-coded in, baked in. We wanted to have this concept of conditional test execution. So at disabled implements that, but you can implement your own. So you can write your own conditions for things like don't execute on the weekend, things like that. Don't execute on the CI server. The funniest I've seen, have to share the story. Some guy wrote a blog and was like, yeah, we have this test that fails rather regularly, and on Friday afternoons after 4 p.m., I don't want to run it because my boss will make me stay and try to fix it. So this is disabled on Friday afternoons. And that you can write code like that. That works. I don't condone it, but you see the magic. So you can check the current time, the current server, time zone, connect to a database, all sorts of things like that. And if you don't want to run things that are disabled, one nice feature is you can deactivate via a launcher system property called JUnit conditions.deactivate, and that's a pattern. It's documented in the reference manual how to do that. But for example, if you didn't want to use this disabled one, you could just say org.junit.star and it'd be turned off, or you could turn off your own. So what you can do is maybe you have a bunch of tests disabled over time and you want to see, are they really still broken? Why are they all still disabled? You can run them all now, and if none of them fail, then just go back and delete the disabled annotation, for example. Interface default methods, as I mentioned before, like with Spring, kind of this idea of testing traits, test interfaces. You can implement multiple of those at a time. In terms of JUnit 5, things that are supported there, your at before each, at after each methods can be on default methods. So you can even have default test methods, default test factory methods, I left that out, and at tag. And you can also have at extend with, so you can configure the extensions you want to use and then have that functionality brought in when you implement one of these so-called testing traits. So you can check out the string tests and user guide, for example, that. Nested task classes, something you may have needed before or looked for, now supported in JUnit 5, and now enables logical hierarchical grouping of your test classes with shared initialization and state. So it's not just like having static nested classes, these are actual inner classes. Basically just declare at nested on such an inner class, and you can even combine these nested classes and testing traits or test interfaces. So for an example of that, I recommend you check out the testing a stack example in the user guide to see that in action. Dynamic tests, one of the cooler things, or people find pretty cool. If we think about conventional tests, we would say they are static in the sense that they're compiled in, right? You can look at the source code and say, I have this at test method, it's there, I know it's gonna run. But sometimes you want to do things dynamically or maybe programmatically. So with JUnit 4, there's a dynamic test that can be registered at runtime, provided as a Lambda expression in a stream collection, et cetera. And that's done within a method that's annotated with at test factory. So these are somewhat analogous to parameterized tests, except that parameterized tests are parameterized by an extension, something external. And for a dynamic test, you can parameterize them, but you parameterize them your own programmatically within your own code. So I will see if I can show that in an example here. I don't think I've ever live coded one of these. I'll do my best to do it right from the start. Stream of dynamic test. Is that going to work? Is that compiling now? Well, of course not, because it's not returning anything yet. Yeah. So we should be able to do something like, I don't know, let's go with A, B, like that. So we have a stream of strings, and then for each of those, we want to map each of them onto a dynamic test. I'm going to that is a unique feature of Eclipse dynamic test. So now I should be able to say something like dynamic test, and then give it a name, and I could say the test for each of these, this is a string coming in, string, maps to, and then I could say the display name is something like test, colon maybe, plus the string, and then the executable could be whatever I want it to be. It could be just some kind of assert true, right? Not going to do anything fancy there for the moment. I would much prefer to sit to do this. What did I get wrong here? Stream of AB map as dynamic test. Anyone see anything going wrong here? That's the stream, dynamic test, map. Is Eclipse being mean to me? Yeah, it's not where's the end? Should be able to collect them all. I'm not sure what's going on there. Okay, demo gods, not in my favor. Dynamic tests, we have some demos, so I can just show you what that looks like here. Basically, that the mention there, the map, and then to the dynamic test, and then the code you want to run, and you return the stream of that, and that will run all of those tests dynamically. Just the return, you're saying? Yeah. But it's still... I'm not sure. That's not important. So let's move on. Sorry about that. Okay, so what's missing? The official build and IDE integrations I mentioned before. That's coming. We have our own plugins. IntelliJ IDE 2016.2 has beta support, so you can actually do it within the IDE without having to use that special runner. Eclipse is on the radar, but probably not coming to 2017. Parameterized tests, parameterized by an extension is not there yet. Scenario tests, kind of like with TestEngine, we have multiple steps with an ordering. Parallel execution, these are things we're looking at. So the last few minutes, I want to talk about Spring Framework 5.0, the new support for this. So we actually have full support already for JUnit 5 with the Spring extension in the latest milestone of Spring 5.0. Supports all of the core framework, TestContext framework support you would like to see or you've seen in JUnit 4, no differences there. But also additionally supports constructor and method injection via @AutoWired, @qualifier, and @value. So you can inject beans into a test method or before each method and stuff like that. It also works with Spring Framework 4.3. There's no official built artifact for that that's published anywhere, but you can check out the code on my GitHub account, Spring Test JUnit 5. You can build it locally, and if there's enough demand, we will actually consider backporting the support in Spring 5 to Spring 4.3 as JUnit 5 moves towards GA. So the Spring extension, again, that's like the SpringRunner, but for the JUnit 5 support, just write @extend with the Spring extension. We have some composed annotations, so you can simplify that. You can just annotate a class with @SpringJUnitConfig or @SpringJUnitWebConfig to have a standard application context or a web one. And I will show a quick demo here in a second, but basically to show bringing everything together. So if you want latest and greatest cutting edge, you can use Spring Boot 1.4 with the new Spring Boot testing features. You can use JUnit 5 milestone 2 and Spring 5 milestone 1 and have that all working. So here I have an example with some custom config doing exactly that. I have my own custom annotation. I like to do this on my projects just to reduce clutter. So extend with Spring extension. Please run JUnit 5 with Spring. Spring Boot test. We saw this in the keynote with a mocked web environment. Auto configure MockMvc, cool feature from Spring Boot test. It's going to create the MockMvc test instance for me, and I can use that. And I'm saying I want my test to be transactional. So this is my custom annotation, and I can use that across my code base. So here we have an example. I'm putting that together. Here's my JUnit 5 test class annotated with that annotation. Getting all of this JUnit 5 Spring Boot magic together. I have a method here, setting a custom display name. The home page should display more than 10 objects. So we have the MockMvc created for us automatically by Spring Boot, injected with Springs.AutoWired by the Spring MVC, integration testing support, and then we can just use that MockMvc, perform a GET request, and assert our expectations. So this is basically the simplest way, the least amount of code you can write when you're on the latest and greatest with Spring Boot 1.4, JUnit 5, and Spring 5. And that's actually all the time we have. I would like to show more demos, but I think I'm not permitted. So thank you for coming. If you have any questions, come up and ask me.